Hey guys, hope everybody's doing okay. What we're going to do right now is take a look at our virtual lab, which is determining the empirical formula of magnesium oxide. So what we would do in this lab is take some magnesium, and we did something similar to this back in Unit 1, where we had magnesium and we held it in that Bunsen burner flame. We turned it into that white ashy product, right? What we're going to do is something similar here. You're going to take some magnesium, put it in a crucible, heat it up, and find the mass of the product that you create after the magnesium combines with the oxygen that's in the air. Once you have that data, you'll be able to do some simple math, some simple mole conversions, and figure out what the empirical formula is. I'll walk you through that process in the virtual lab that you guys are going to do. So the introduction gives you an idea of, or a review of, what an empirical formula is, and basically how to find that. And you want to knock out the pre-lab questions first. So number one says, what's the difference between an empirical and molecular formula? You guys can use your notes, your class notes, to answer that question. You should be able to do that pretty easily. And number two says, why do you think you heated the crucible in step number one? So if you scroll down to the directions, if we were doing this in class, step one of the procedure says, using a ring stand and a clay triangle, along with your crucible and lid, you want to heat it up in the hottest part of the Bunsen burner flame and have it glow red for 5 minutes. And to make sure the lid is on top here, slightly ajar. Allow it to cool and find the mass of the crucible and lid. So you do that, and here's the data for you. The crucible and lid is 32.10 grams. Why do you think we heated that up before we actually did the rest of the experiment? The answer to that question is so we can get any impurities or moisture, specifically moisture that's in this crucible. We want that to be evacuated, right? We want that impurity, we want that moisture to be gone. We want a really, really, really dry crucible, so we know that all we have there is the crucible. And then when we add our reactant to it, and then we eventually have our product in there, we know that all we have in there is a reactant or product. All the initial moisture and impurities are gone. Okay, so that's why we have to heat the crucible in step number one. Before we get to the rest of the procedure, number three is a little practice calculation for you. So calcium reacts with oxygen to form calcium oxide. 2 grams of calcium burns to form 2.8 grams of calcium oxide. Calculate the empirical formula of the calcium oxide. So what we really have here is calcium plus the oxygen in the air, and that is going to produce some calcium oxygen product, right? And we pretty much know what it is from our nomenclature unit, but it's Ca something O something. So let's say we didn't really know how to do that from the nomenclature unit. How can we figure this out? Well, we're starting with 2 grams of calcium. So we have 2.0 grams of calcium. We don't know how much oxygen is being added to it, right? But I do know that the final product is 2.8 grams of calcium plus oxygen. Okay, so we can use our law of conservation of matter and determine that we have 0.8 grams of oxygen added to this system. All right, so what we would do next is we would have to convert all of these reactants into moles, right? We know that an empirical formula is the lowest whole number mole ratio. So we're going to take calcium, the 2.0 grams of it, and convert that into moles, doing a one-step mole conversion. All right, so molar mass of calcium, 40.08 from your periodic table. And you have 1 mole on top. And that's going to give you some value, right? And we also have our 0.8 grams of oxygen. Right, now in the reaction, it's in the molecular form O2. We haven't really quite learned about this yet. So it's just, we know 0.8 grams of the element oxygen reacted with the calcium. So let's convert that into moles as well. So from our periodic table, it's 16.00 grams of oxygen and 1 mole of oxygen. Okay, so what you'll do is take 2 divided by 40.08, get some number. 0.8 divided by 16.00, get some number. Then remember, to find the empirical formula, you divide through both of them by the lowest number, whichever one of these is lower, and that's going to give you your mole ratio. All right. If you figure this one out, you should get a mole ratio that gives you the correct empirical formula for calcium oxide. So I'll let you guys finish that as part of your pre-lab, but that's how you would generally set that problem up. As you go through and read the procedure, you'll write down this data in your data table. So we have our empty crucible and lid, 32.10 grams. Place your magnesium inside of it, crucible lid and magnesium, 32.32 grams. So you can see the difference here, how much magnesium you added to your crucible. Heat it up. Don't look at it. It's going to be hard to look at it virtually, but you wouldn't look at it because it glows really bright. And you'd heat it for a long time until you end up with this gray, ashy, white product, which looks familiar to us from Unit 1. So the crucible lid and the magnesium oxide is 32.45 grams. Okay, so we only have 3 pieces of data here. So crucible and lid from step 1, mass of crucible lid and magnesium from step 2, mass of crucible lid and magnesium oxide from step 4. Okay, so the only difference here is we have our crucible and lid. Here's crucible lid with the magnesium. And after you burn it, the oxygen is added into it, crucible lid and magnesium oxide. So what you want to do is go through the calculations and show your work. Show some work here to get credit. Determine the mass of magnesium used, okay, from these 3 data points. Convert that to moles of magnesium, all right, simple mole conversion. Find the mass of magnesium oxide that's formed. Okay, so you got to do some subtraction here. And then find the mass of oxygen that combined with the magnesium. So there's a couple ways to do that. You can use your data up here, right? There's another way to do it as well, but just a simple subtraction problem. So find the mass of oxygen that was combined with the magnesium. So you want the difference between the magnesium mass and the mass of magnesium oxide to find out what your oxygen value is. Find the moles of oxygen. So you're going to do a mole conversion once you have your mass. These are all simple one-step things. And then for question 6, use your answer from number 2 and number 5. So number 2 is the moles of magnesium, 5 moles of oxygen. Find the empirical formula. Once you find the empirical formula, show your work here to calculate the molar mass. All right. Once you do that, you can turn it in and submit it. You should be able to check your work, so you should know what the formula for magnesium oxide is from our nomenclature unit. This is to verify that it is correct. When you get your mole ratio, even if you went back up to the pre-lab here, if your mole ratio is like 1 to 1.07, like, well, what kind of ratio is that? Well, I mean, you're going to round, like, you're basically rounding all these, right? You're not going to get 1.00000 to 1.00000 through lab data. There's always some sources of error involved. So if you end up with a ratio of like 1 to 1.07, it's a 1-to-1 ratio, all right? So same thing down here. As long as you're really, really close in this section, as long as you're really, really close to a whole number, you probably did it correctly. Okay, if you have any questions, let me know. But it's pretty straightforward. It shouldn't take you too long, and it kind of replaces a wet lab we would do in school. All right, thanks, guys.